Hello, my name is Javier Andrés Esquivias Varela, and I will present the paper Implementation of an Intelligent Framework for the Continuous Improvement of Industrial Process using an avatar adapted to the context of Industry 4.0, presented at CELOC 2020. Introduction. Industry 4.0 requires a uniform and standard model for the review of the ergonomics associated with a group industrial process. For this purpose, the use of an avatar that obtains tacit knowledge is recommended to better describe an adequate training. Then it can be associated to the implementation of a model that analyzes a set of actions to be performed within the intelligent manufacturing paradigm, as well as linked to the adaptation of highly specialized environment associated to the state-of-the-art industrial requirements. The variability of movements, it provides adaptability and flexibility, which are essential to meet the personal characteristics of the workers and the specification of the task to be performed, taking into account environmental constraints. Prototype integrated equipment that allows the measurements of very diverse types of physiological signals, facilitating the acquisition, processing, and transmission of the signals to be evaluated in a monitoring and diagnostic center. Staff recruitment, it must be considered in the context of the easy of free body movements that can be performed by the human being, helping positioning and natural efforts, avoiding complicated and unnatural movements due to muscular problems or any fissures in the bones due to accidents during the life of the person in question to be analyzed. Data capture. The data capture is managed through the database libraries along with the Python software, which can meet the service request. It can process the necessary basics values that will be evaluated by processing from the other entities. Prototype working scheme. The aim is to automate the location of the body reference points and the calculation of anthropometric measurements based on digital human models generated by 3D scanning with deep cameras. The data and files are stored in a local database immediately after production. Optionally, registered users can copy the data and files stored in a centralized document management system that allows long-term preservation and decentralized access. The control model is a chatbot that works in interconnected symbiosis with a simulation avatar that represents the movements of the human being, which is a replica of a real-time simulation of the natural movements of the human being. In this way, the movements can be captured, later processed in a database that works in conjunction with another database previously loaded with information or acceptable parameters of the movements so that the program can later interpret the captured information, giving as a result a simulation of the avatar as a whole of the movements of the person in question. Outline of the working protocol to achieve a symbiosis or a prototype for the project to be carried out. The design tools. This refers to the technical specification of the hardware needed to carry out the prototype, which must work in a complete harmony with the program to be implemented, as well as the database of the different software that will be integrated into the prototype. We can listen the software line, Unity, Python, Microsoft SQL, Windows 10 64, Pro, and the Kinect software. In the part of the development kit, chatbot, AWS Avatar Virtual Station. And for the hardware, high resolution 4K screen, Microsoft Azure Kinect, and the computer that has to have a minimum of requirements that the Kinect provider asks us for its operation. Design and methodology. These are the basic needs that were raised in order to seek the objective of the project, thus giving a clear vision of the direction in which we should focus analysis and specifications, where we can include the scalability of the project. Criteria of the prototype. The prototype is intended to be optimal and easy to use for both the operator and the people being analyzed. So we can focus on the following criteria to achieve this goal. Easy of use, user-friendly interface and functionalities so that the user can produce the basic movements that will be simulated through an avatar. Agility, immediate evaluation of the results so that the user can obtain the necessary measures applicable to the work and the personnel to employ. Transparency, preserving all the necessary data for the verification and reproduction of the results at any time. Dependence, dependence on the brand or model of the scanner equipment, since it will work with products from the Microsoft company, which have very high standards and quality levels, both in software supply in the hardware, Kinect Azure deep cameras. For the creation of the 3D model, a digital file must be provided, which will be unique for each test to be evaluated. Persistence. The simulation can be repeated several times in case the person to be analyzed does not understand the movements of the simulation. Flexibility. The design of the simulation will be available to make the necessary modifications required by the evaluator at the time of the making the diagnosis, thus seeking greater flexibility in the variety of tasks to be performed within the simulation. All the data recorded in the model and the questions are available for use. Age, gender, weight, movements, and posture. Below is the general scheme of the prototype with the distribution of its arms that we will explain. In the central part, we find the chatbot, which is a virtual intelligence program that integrates the functions of the previously programmed programs and we can have access to the system. Then we have the deep cameras, Kinect Azure, that will capture the movements of people and will be represented by an avatar in a Unity scenario on a high quality screen. The prototype includes a database of tacit movements that, in combination with the database of another ontology interactive movements, will help us to identify the person's ability to move freely, and then generate a result based on each of the character analyzed. A high-performance computer is necessary because it will connect the deep image camera, Kinect, which will in turn store the information in the database that are in the computer. This will connect the high resolution screen through an HDMI cable that represents the virtualization of the avatar. Understanding that 3D virtualization have a high consumption in the performance of the computer. That is why it is necessary to have detailed specification of the equipment. The PC host requirements for body tracking is more stringent than the general PC host requirements. The minimum recommended configuration of the body tracking SDK for Windows is 7th generation Intel E5 processor, a quad-core 2.40 GHz or faster, 8 gigabytes of memory, and an NVIDIA GeForce GTX or higher, dedicated USB 3 port. A key part of the project is based on virtual reality glasses, for which we will use the Oculus Go, autonomous virtual reality headset. This can be connected via Wi-Fi to the PC without the need for connecting cables. This allows greater mobility to the person under assessment. Finally, a report will be generated with a detailed information about the person movement capacity for business use. In this image, we can clearly see a worker performing an operation at her workplace that involves having her shoulder lifted throughout the working day. Assuming that this person has a shoulder problem, it will cause her shoulder pain, therefore decrease her work performance. The aim of this prototype is to redirect staff to a workplace where they can work freely and without complications due to their muscle or skeletal problems. Avatar on the Unity. The virtualization of the prototype will be designed in an environment that uses Unity in conjunction with the designed avatar in order to generate the necessary scenario that will be followed by the users. Work together with the Kinect Azure and Microsoft SDK software development kit is intended to capture the movements in real time. Measurements will be in T equal time and equal number of actions and NP number of processes. Now we are going to see a video. In the video, we can clearly see a simulation of the analysis of the corporal movements of any individual, where the corporal angles at the movements of doing the corporal movements can be appreciated. With this type of information, it is possible to be analyzed if the person is up for some station of work that has been previously analyzed and it has the information of which restrictions or cannot have the person to be contracted or hired. Case study. The information collected by the prototype can be adapted and based on the evaluation results can be generated instantly. The operator of the forklift truck in question must be able to perform the basic body movements to perform the necessary functions within the job. You can also clarify with the following case virtualized in Unity, the obtaining of results in various models of captures, and with this, it was possible to solve the problem in question. For this investigation, three factors, shifts, units, and days, are analyzed to determine the loads. Terms of three moments, M, T, and N, where M equals AM, T equals 12 p.m., and N equals 6 p.m. This is because you want to identify which route is to be demanded. There, three units are analyzed, R5, R12, and R23. Finally, the days of the week from Monday to Friday are analyzed. D1, D2, D3, D4, D5. Where D1, Monday, D2, Tuesday, D3, Wednesday, D4, Thursday, and D5, Friday. Some are statics to determine the industrial process to be modeled. Factors to be analyzed. Capacity statistical variables are shown. There are a total of 45 records that identify the time, unity, day, and capacity. The objective of the experiment is to analyze the capacity variable and identify where there is more demand. We can see the distribution, and in the part of the forklift turns, the shifts with the most loads on the end, approximately 290, followed by the T. In the shift from 12 p.m. to 200 and less load on the end. This is at 8 p.m. People do not demand the same. The capacity for shifts. The following graph shows a higher capacity for turn, identifying that M turn more capacity for the R5 unit, while for the same turn, the R12 unit is the lowest demand it has. Conclusions. The evaluation of human body movements has a common practice is not yet adapted to the Industry 4.0. Observing within the natural parameters of body movements to decide the final location of people to be hired. Therefore, minimizing engineering costs in workstation for an ergonomic fit. To be able to guarantee a workstation in the quality of the person hired and without problems that prevent free body movement that allow a better work performance. The final standard for the Internet of Things have not yet been defined. In fact, the protocols are in full development and there are several projects that aim to define standards. Today, many business sectors face several communication challenges. Thank you.